Okay, so definition of a trigonometric function: let t be a real number, let p of xy be the terminal point on the unit circle determined by t. Then we define the following. Okay, the first one is sine of t. This is going to equal y, the y coordinate on that terminal point. Cosine of t is going to equal x, the x coordinate of the terminal point determined by t. And tangent of t is going to equal y over x, the quotient of this guy divided by that guy. X cannot equal 0. Cosecant t, which is going to equal 1 over y. Y cannot equal 0. Secant t, which is 1 over x. X cannot equal 0. And then finally cotangent t, which equals x over y. And here, y cannot equal 0. This is the sine function. This is the cosine function, cosine of an argument t. Tangent function, tangent of an argument t. Cosecant of t, t is the argument. Secant of t, t is the argument. Cotangent of t, t is the argument. We are defining this. This is what we were defining to be the 6 trigonometric functions. You must memorize these 6 things. It is crucial that you've memorized each and every one of these. Sine of t is the y, cosine of t is the x, tangent is the quotient of y over x, and so forth. Okay, so up here I've drawn, again, all rewritten, all our trigonometric functions and the definitions. I've drawn a little unit circle over here, and my question is find the 6 trigonometric, trig for short, functions for the given real number t. So I want to list out all 6 of these values given that t equals pi over 3. So if we have t equals pi over 3, what we have to first do is find the terminal point associated with this value of t. Okay, so the terminal point associated with that value of t gets us to right over here, okay, which is 1/2 comma root 3 over 2 for a t value of length starting at 0.10, wrapping around pi over 3, that's t equals pi over 3. The terminal point associated with that is the point 1/2 comma root 3 over 2. So therefore I can then find my 6 trigonometric values. So if I want to find sine of pi over 3, cosine of pi over 3, tangent of pi over 3, cosecant pi over 3, secant pi over 3, and cotangent pi over 3. I used the fact that the terminal point is 1/2 comma root 3 over 2. So sine of pi over 3 is the y value there. It'll be root 3 over 2. Cosine of pi over 3, cosine is the x value, so it'll be 1/2. Tangent of pi over 3 is the quotient of the y over the x value. So I'll have here my y, which is root 3 over 2, divided by 1/2. So it turns out to just be root 3. I have to do the mathematics, right? This guy divided by that guy, the 1/2s cancel out. Cosecant of pi over 3. Cosecant of pi over 3, you'll notice is a reciprocal of y. 1 over y is a reciprocal of y. Therefore, it'll be 1 over this y value. So it'll be 2 over root 3, rationalize the denominator, multiply top and bottom by root 3, and I'll have 2 root 3 over 3. If I look at the reciprocal of this, you just get 2. And if you look at the reciprocal of root 3, you'll multiply you'll have 1 over root 3, multiply top and bottom by root 3, you'll get root 3 over 3. Okay? So these are the 6 trigonometric functions that are all simply based on the fact that the terminal point is 1/2 comma root 3 over 2, as defined by t equals pi over 3. Now, suppose we have t equals pi over 2. So if I have t equals pi over 2, we note that the terminal point associated with t equals pi over 2. So here's pi over 2 length around the circle. This is t equals pi over 2. The terminal point here is the point 0, 1. So therefore, if I want to calculate all the 6 trigonometric values for it, sine of pi over 2, cosine of pi over 2, tangent of pi over 2, cosecant pi over 2, secant pi over 2, and cotangent pi over 2. Again, all I'm doing is I'm looking at the terminal point. So sine of pi over 2. Sine is the y value. What is the y value over here? Well, it's 1. All right, good. I put 1 there. Fantastic. What's the x value over here? Well, 0. It's fine, I put 0. What is the quotient of y over x? Well, that's undefined. 1 divided by 0 is undefined. You cannot divide it by 0. It's undefined. This is undefined here. 0 in the denominator is bad news. Cosecant is defined to be 1 over y. 1 over 1 is 1. Again, we're just doing the reciprocal of these, really. Now we're doing 1 over 0, which is undefined. And now we have x over y, which is the reciprocal of 1 over 0, which was undefined, so it'll be 0 over 1, which puts that at 0. Okay, so now what we have is we have the domains of the trigonometric functions. These are functions. They have domains. Domain is what values are allowed to be put in. In other words, what numbers is it allowable? And I don't get a problem when I put it in for sine and cosine. Well, if sine is always the y-coordinate and cosine is always the x-coordinate, guys, we can put anything we want in here. Because no matter what your x or y coordinate is, they're numbers. X coordinates and y coordinates are numbers. We're always going to have values for that. So the domain of this thing is all reals. Okay? Okay? However, tangent, what's the deal with tangent? Tangent and secant, we can't have any value of x, can't have any x coordinate that is 0, because you can't divide by 0. Okay? Tangent and secant, you can't have a 0 in the denominator. 0 in the denominator is bad. You can't divide by 0. So when is the x value 0? Well, the x value is 0 here at this point, right? And at this point. So the t values associated with this point and this point are not in the domain. Okay, fine. So what t value is the first one? The first t value would be, that t value right there, well, that's pi over 2. So that's a bad one. Pi over 2 is bad. Okay, pi over 2, bad. Not everything, so everything's okay except for pi over 2, and also, what value of t is that? Well, that's 3 pi over 2. But we can keep going. So if I started here and went whoosh, all the way around, what's the value of that? Well, that's just 2 pi plus this thing, correct? Well, 2 pi plus this, that's 4 pi over 4, so it's 5 pi over 2. Right? Okay, fine. But then it's also 3.5 pi plus another 2 pi. Well, what's that? That's 7 pi over 2. So these are all bad values. Again, bad, 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 bad. And I think you see the pattern. 1, 3, 5, 7. So it's all reals. Let me write it a little bit nicer so you can see it. We agree that these are all bad. Da, 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 da. Those are bad guys. So the easy way to remember it is if I write all the real numbers except what? Except pi over 2 plus any integer multiple of pi. Integer like -1, -2, or 3, or 7. All reals except pi over 2 plus any integer multiple of pi. So like a pi, or a 2 pi, or a 3 pi, or a 4 pi, that type of thing. So it's all reals except for this, where n is an integer. Okay? So the domain, sine and cosine, all reals. Domain of tangent secant, all reals except for the ones that give us 0 in the denominator. When does that happen? At all the pi over 2, 1 pi, right? 3 pi, 5 pi, 7 pi over 2, okay? Except for those, okay? Now, when is cotangent and cosecant not defined? Well, when the y value is 0. When is the y value 0? Well, it happens here and here. That's when the y value is 0, right? The y value is 0. You can't divide by, you can't divide by 0. So, it's all reals, any number can be put in, except for the ones that make the denominator equal 0. So it's all reals, except, right, pi, 2 pi, 3 pi, 4 pi, okay, except n pi, where n is an integer. Okay, so this is the domain. These are the domains of these given functions. You need to know what the domains are. Again, the domains are when everything is okay. Whatever number you put in does not give you an undefined number. You can't divide by 0. That is critical. Okay, so the following trig functions are positive in each quadrant. Okay, what we do is each of these 6 functions are either positive or negative in any given quadrant. In quadrant 1, all of them are positive. We remember all students take calculus. It's an easy acronym to remember. All of them are positive in here. So we'll go ahead and write all of them are positive in here. And if in quadrant 1, all of them are positive, therefore none of them are negative. Very good. In quadrant 2, all students, S, students, sign. So sign here is positive. But if sign is positive, that means this is a positive value. 1 over y is a positive value because y is positive. Therefore, cosecant is positive. Therefore, all the rest are negative. Cosine, secant, tangent, cotangent. Very good. Okay, quadrant 3. Take starts with t. What starts with t? Tangent. Fantastic. So that means tangent is positive. Therefore, that's the positive one. The quotient y over x is positive. Therefore, x over y is positive. Therefore, cotangent is also positive. All the rest are negative. So, sine, cosine, cosecant, and secant. And then finally, quadrant 4, calculus, cosine. So if cosine's positive here. Well, what's cosine? Cosine is x, so therefore 1 over x is positive, because 1 over positive is positive, so secant is positive, and the rest then would be negative. Sine, and cosecant, and tan, and cotangent. So this little acronym, all students take calculus, allows us to get the signs of all 6 trigonometric functions in any quadrant.